Okay, in section 6-3, we are proving that a quadrilateral is a parallelogram. Now, we're not actually going to spend time writing proofs, okay? What I find to be more important here than actually writing a proof, since we already did a big section, a big chapter of writing a whole bunch of proofs, what I want you guys to be able to do is to look at a quadrilateral and tell me whether or not it's a parallelogram. Because if we're solving for a missing angle or we're solving for a missing side length, we have lots of properties of parallelograms that are useful in finding missing lengths, right? And so if we don't know, or if we're not given the fact a quadrilateral is a parallelogram, it is helpful to find out that it's a parallelogram so that we can use those multiple properties that we know. Okay? So we have, gosh, what do we have here? 6, I believe? Nope, 5. We have 5 properties today we'll talk about that allow us to say whether or not we have a parallelogram. So starting out with 6-8. Theorem 6-8 says that if we have a quadrilateral and if we know that the opposite sides of the quadrilateral are congruent, then we have a parallelogram. This happens to be the converse of Theorem 6-3 that we talked about last Friday, I think it was. Okay? Theorem 6-3 said that if we have a parallelogram, then opposite sides are congruent. Well, this is the converse of that. Remember converses from way back when? Right? We had if-then statements, which, by the way, all of our theorems we talk about in this class are always given to us as if-then statements. They're called conditional statements, if you remember. Well, the converse is where you simply switch the if and the then. Okay, so this is the converse of Theorem 6-3. All right, taking a look at 6-9. And Theorem 6-9 says if an angle of a quadrilateral is supplementary to both of its consecutive angles, then the quadrilateral is a parallelogram. This isn't quite the converse, but it's awfully close to the converse of Theorem 6-4. Okay, Theorem 6-4 says that consecutive angles in a parallelogram are supplementary. Well, in this one, we of course have to have a quadrilateral, but we are talking about the same angle. For example, in this they talk about angle A. If angle A is supplementary to angle B and angle D, okay, if one angle is supplementary to both of its consecutive angles, then we have a parallelogram. Okay? Looking at Theorem 6-10. Theorem 6-10 is the converse of Theorem 6-5. Okay, and this theorem says that, again, we have to have a quadrilateral. But in a quadrilateral, if the opposite angles are congruent, then we have a parallelogram. Okay. Theorem 6-11. In Theorem 6-11, this is the converse of Theorem 6-6 from the other day. And this one says that if we have a quadrilateral where the diagonals bisect each other, if it's a quadrilateral where the diagonals bisect each other, then we have a parallelogram. Okay? So all of those theorems were converses of previous theorems that we had. Okay? All those properties of parallelograms, These are just the converses of those. But Theorem 612 is a new theorem all of its own. Okay? So Theorem 612 says that if we have a quadrilateral, if we have a quadrilateral and one pair of opposite sides are both parallel and congruent. If one pair of opposite sides are both parallel and congruent, that is then enough to say that we have a parallelogram. Okay? Questions? Now, I had shown previously why those other theorems worked, meaning I've shown you why Theorem 6.3, 6.4, 6.5, and 6.6 work the other day. And our new theorems today are just converses of those. But let's look at 6.12 quickly. Why is this able to show us that we have a parallelogram given this information? Well, again, like the other theorems, we need to use triangles. We need to look at the diagonals. So if I draw in a diagonal here, since I have parallel lines, I have alternate interior angles that are congruent. Okay? And I have congruent segments, BC and line segment AD. They're congruent, and I can also say that this diagonal is congruent to itself by the reflexive property, giving me congruent triangles according to side angle side. Okay? Since I have congruent triangles according to side angle side, I then know that this side is congruent to, oops, I need 3 marks there, congruent to that side, because they're corresponding parts of congruent triangles. And now I'm able to say, well, wait a minute, we had just talked about a theorem there. That's Theorem 6-8. Theorem 6-8 says, hey, if the opposite sides are congruent, then it must be a parallelogram. Okay, so that's how this theorem is able to get us there. All right, again, it's a shortcut. It's one of those handy things that if we have one set of parallel sides and that set happens to also be congruent, then we can say we have a parallelogram. Well, why are we going to see these things? There's a little setup I want to show you here. For example, just off to the side here, what if I gave you this? And this is what you're going to see in your homework quite a bit. Okay, this is what the homework is going to be like, which is why we're not going to spend a lot of time on this section. If I have this, and let's go ahead and say that this is, let's keep it easy. Let's say this is 80 degrees, this is 100 degrees, and this is x. Okay? All they're going to ask us for in most of your problems you'll see is what value of x makes this a parallelogram. Okay, that's all they're going to ask you. Okay, so really what you're doing here is it's almost like you're just saying, okay, well, let's just assume it's a parallelogram, and then we can use our properties. Right? Because then we can say, okay, yeah, opposite angles are congruent. Okay? What they're technically saying here is, well, what value of x makes this a parallelogram? So they're saying, all right, well, we need to go over and use, actually, this would be Theorem 6-9. Okay? For this problem, they're actually wanting you to use Theorem 6-9 and say, well, if the consecutive angles to the same angle are supplementary, then it's a parallelogram. So these are supplementary. So therefore, if these are supplementary, then it's a parallelogram. I mean, that's all. Either way, you're finding the same value of x, right? When x equals 100 degrees, then we have a parallelogram. So that's essentially what most of your problems are going to be. It's still using the exact same properties as from section 6.2. All right? Any questions on that? Now let's look at the backside. There will be a couple of proofs, but again, I'm telling you that we're not actually going to be writing the proofs, okay? Instead, I want you guys just to think through the proofs. Instead here, we're just kind of going to think through the proofs. So, for example here, we have that AB equals 5, CD equals 5, the measure of angle A is 50 degrees, and the measure of angle D is 130 degrees. We want to know, is ABCD a parallelogram? So, what I want you to do, rather than sitting here writing a formal proof, I want you to say, well, we know certain things. We know that line segment AB is congruent to line segment DC, right? We know that they're both 5 units. What else do we know in this diagram? Positively, 100%, we know what? We know that angle A and angle D are supplementary. Remember, we're not writing a formal proof. We don't need to go specifically step by step by step. I don't need to say, okay, angle A is 50 degrees, angle D is 130 degrees. If I add them together, I get 180, therefore they're supplementary. We know they're supplementary. We can look at that and say they're supplementary. Okay? But what does that tell me? The fact I have supplementary angles. Is what we have right now enough to say we have a parallelogram? Looking at our 5 theorems on the front side of our notes. Some of you might be looking at the theorem that says that we have supplementary angles, right? Consecutive supplementary angles. The problem is I don't have 2 pairs. I have A and D, but I don't also have A and B or D and C. So I don't have that theorem. What was that theorem? 6-9, I believe? Yeah, I don't have theorem 6-9. Okay? So I can't use that one. Okay? Okay, so we're thinking maybe 612. And we're thinking 612 maybe because we have the one set of congruent sides, but we don't have the other set. But we're not there yet because I don't actually have anything saying I have parallel lines. But I do have supplementary angles, consecutive supplementary angles. And if you look closely here, don't they make that C shape we talked about many, many moons ago? Those angles were called same-side interior angles. Same-side interior angles, or we also call them consecutive interior angles, are supplementary only when lines are parallel, cut by a transversal. So therefore, because of that, we can prove, I can prove that line segment AB is parallel to line segment DC. And now I know that ABCD is a parallelogram by theorem 612. Okay? So, I'm wanting you on these problems to think through the proof, to think through the logic, but you don't actually have to write the formal proof. Okay? Understanding what I'm asking here? Yes? No? Maybe? Okay. Let's take a look at the next problem. In the next problem, can we prove that HIJK is a parallelogram given that information?
No. No.
I heard yes, I heard no. Why are you saying no?
Because it's not the opposite sides that are congruent.
We have 2 sets of congruent sides. I agree with that, but they're not the opposite sides. In order for us to show that we have a parallelogram, the opposite sides have to be congruent. And there is no information in this problem telling us that these segments are the same length. Okay? Maybe those are the same length. Maybe this is a parallelogram. But we don't have that information. We're not given that information. So as far as I can tell, this is not a parallelogram. As far as the information given to me, it's not a parallelogram. All right, taking a look at the next example. Do we have enough information there to say we have a parallelogram? You're thinking yes. How? Are we able to say it immediately by a theorem, or do we have to do a little bit extra work?
Yeah, no, not at first.
Okay, not at first, you're saying. All right. So that means we need a little bit extra work. Anybody see what we need to do here? What extra work?
You need to make D, E, and G, F.
Okay, well, DE, so you need to make those line segments congruent. How? Well, a lot of times in this situation, I want to go through, because we don't know we have a parallelogram. All we know is we have parallel lines. So I could say that angle E and angle F are supplementary because they're consecutive interior angles. I could say D and G are supplementary because they're consecutive interior angles. The problem is we don't have consecutive angles from the same angle, right? That's what we need for that theorem. We need them all to be, supplementary to one angle, which we don't have, so we can't do that. And so then I draw in, a lot of times, drawing a diagonal. Sometimes diagonals help us. So if I draw on a diagonal and look at that.
Wait, I was just asking, can I ask a question?
Yeah, I'm sorry. What's up?
Can't you just make angle D and angle F congruent because they're parallel lines?
Angle D and angle F. No. We can't say angle D and angle F are congruent because we have parallel lines. Because they don't fall into any of those properties we had as far as parallel lines, meaning they're not parallel lines cut by a transversal. D and F don't actually go together, because we could say that D and G are supplementary. We could say that E and F are supplementary, but there's no way of referring to G and F or D and E to get us there. Okay? And the reason is because we don't know that DG and EF are parallel. We don't have that second set of parallel lines to work with. Okay? So yeah, it would be nice to be able to say that, but we don't have the information right now to say that. So looking at this then, I drew in a diagonal. That allows me to say that this angle and this angle are congruent because they are alternate interior angles. I can also say that this side here, the diagonal I just drew, is congruent to itself by the reflexive property. Okay, wonderful. Well, does that help me? Is that giving me enough information to say that I have a parallelogram? No. Why not? Do I have congruent triangles?
Yeah. No.
No. I don't have congruent triangles, because these triangles are trying to say that they're congruent by angle side side. Nobody likes an angle side side. So we cannot use that, right? Okay, so we're not using that. So no, we don't have congruent triangles, and there's no other information I can pull. Like I said, I could show that a couple of angles are supplementary, but there's no other congruent angles I can use or congruent sides that I can use to show that I have a parallelogram. So, again, this might be a parallelogram. I'm not saying it's 100% not a parallelogram. What I am saying is by the information I'm given, I don't have enough information to positively say it. Okay? So by what I am giving, this is not a parallelogram. Okay? Like I said, it might be a parallelogram, but from what I'm given, I cannot prove it. Okay? Questions? Let's try one more. This last one here. Again, given that information, are we able to say that we have a parallelogram?
Yes.
You think so. Why?
Because if there's interior angles or opposite, no, what is it called? I can't think of
I believe the word you're looking for starts with an A. Alternate?
alternate interior.
Oh, alternate interior angles, certainly.
The opposite, the lines are parallel.
Okay, so you're saying that we have alternate interior angles here, which are congruent, and that only happens if we have parallel lines. I 100% agree with you. That was a theorem from way, way back. Well, guess what? We have a second set of alternate interior angles, meaning then that these segments are parallel to each other. So now my question is because we have alternate interior angles, I'm just going to say because two sets of alternate interior angles, then LA and D is a parallelogram. Why? We've shown that. We've shown that we have those parallel segments. So then why is it a parallelogram?
Oh, 6-6.
Nope.
Nope.
What does 6-6 say? If it's a parallelogram, then the diagonals bisect each other.
Just kidding.
Huh? Nope. 612 says if opposite sides are parallel and congruent. We have not shown anything's congruent. 610 says what?
That if you have both pairs of opposite angles of a quadrilateral are congruent.
Nope. We haven't shown anything about the angle A and angle D being congruent.
There's no.
Oh, there is.
What?
This is absolutely 100% true. But it's not by a theorem. This is by the definition of a parallelogram. What's a parallelogram? A quadrilateral where opposite sides are parallel. We've shown the opposite sides are parallel. Therefore, we have shown it's a parallelogram by definition. Is this the only way you could have done this problem? Absolutely not. We could have, and I'm not going to write on this right now because some of you are copying this down, but we could have said that line segment LN, is congruent to itself by the reflexive property, which we know. We know that's congruent to itself by the reflexive property. And therefore, this triangle and this triangle are congruent by angle side angle. And since those triangles are congruent by angle side angle, that would mean these opposite sides are congruent to each other because they are corresponding parts of congruent triangles. And therefore, we have theorem, I can't think of the theorem number off the top of my head, theorem 6.8? Yes, theorem 6.8 from today, that if the opposite sides are congruent, then it's a parallelogram. That would work. We could also go through and show the opposite angles are congruent. It takes a little bit more work to do that. But if we have congruent triangles, then we know angle A is congruent to angle D. And since those sets of angles are congruent, then we're going to know the large angle ALD is going to be congruent to angle AND. And so then, yes, we could use that theorem to show that since opposite angles are congruent, then it's a parallelogram. There's lots of ways. We could do lots of things. In fact, I really think we could go through and show that each one of those theorems that we use, each of the 5 ones we learned today, could have worked. But some of them take more work than others. Okay? One thing I want you to remember from way back when we were doing proofs, don't forget that the definition of the object you're working with is a reason that the object is what it is. Okay? It's not always a theorem or a postulate that are your reasons. It could just be the definition. Okay? All right. This is how I'm wanting you to do your proofs today. I think there's 2 or 3 of them on your assignment today. I want you to write it out like this. Now, it's possible in your homework that, like the 2 examples we have, that it's not going to be able to be proven. But if you can, write it out. Explain it to me a little bit. You don't have to actually write the proof. If you feel writing a proof is easier than doing what we just did, then by all means, write the proof. Okay? But really all you need to do is explain it to me. How do you know it's it's is what it is. Okay?